Okay, so I made up this problem out of reading some of the book because I just put a bunch of things together and came up with this. So if it makes sense, it makes sense. If it doesn't, then oh well, we'll try again. Okay, an atom on a merry-go-round whose position is 11 meters from the center. It makes one rotation every 12 seconds. First, how far does the atom go in 12 seconds? 2. What is the speed of the atom? 3. What are the magnitude and direction of the net forces acting on the atom? Alright, the first one's pretty easy. It's the distance. All you need to know is the circumference, which is 2 pi r. So we have 2 pi, our radius is 11, so we have 69 meters that it makes in one rotation. Second is the speed. The speed is distance over time, which is our distance of 39 meters over our 12 seconds, which gives us a speed, velocity of 5.75 meters per second. Now, number 3, magnitude and direction of the net force. Well, whenever you're figuring out net force in general with the momentum principle, you always need the mass of the object. So, we're going to find the mass of an atom of iron on the Ferris wheel. The atom has a mass of 9.28 times 10 to the 26 kilograms per atom. We found that by just taking the atomic mass of the atom and dividing it by Avogadro's number. Okay, now that we got the mass, we can move on to the force. The net force, in this case, in the parallel direction, would be the derivative of the momentum principle, which would come out to dp over dt. And since this is moving at a constant rate, it is 0. So that factor equals 0. Then net force perpendicular, which is the same thing. Take the derivative of the momentum principle, and if you work it all out, it comes out and makes this nice little problem of mass times velocity divided by the radius. That being said, we can use this problem because the direction of the force is turning towards the center because it is going in a circle. To find net force, we would take the mass of the atom that we figured out, which is 9.28 times 10 to the negative 26, times our velocity, which is 5.75 meters seconds. We square it, and then we divide it by the radius, which is 11 meters. Our answer that we get is 2.79 times 10 to the negative 25th newtons. Now I know that might seem like a really small number, but we are talking about an atom here. So the atom really has no mass, hardly whatsoever, to speak of itself. So it sounds about right. Thanks.